Hello, Paul.
Hey, Randy, how are you?
Fine, brother. How are you?
I'm doing excellent. Did you have a good New Year?
Not even going to talk about it. Yeah, stayed home, tried not to be infected in the most infected place on the planet,
Yeah, right.
California.
Actually, Miami's pretty bad too.
Well, every place is bad. It just it's just horrible and sad and crappy. Oh well.
Yeah, can't wait for this to be over and get back to normal operations here.
Yeah. Well, I think September probably.
It's actually been pretty good for me because everybody's stuck at home and they want their machines fixed. So I'll be getting.
Yeah, there's always a little silver lining somewhere. And hello, Sean. I don't think we've met. Have we met, Sean Benson?
It looks like he's still muted.
Hello, Sean.
Hi.
Hi.
Sorry, I'm just putting away my stuff here.
It's
No,
okay.
we haven't met.
Hey. Well, nice to meet you.
Yeah, nice to meet you.
You have some sort of a what is that attached to the wall behind you? It looks like a Texas Instruments calculator. What the heck is that?
Which way?
That? Oh, done. Right behind you with the display. It's the white thing on the wall.
No.
No,
Just a breaker panel and
no. Immediately behind your head.
Tempest.
Behind your head on the wall, attached to the wall, the white thing with all the buttons on it.
Oh no, it's just like a garbage can.
No, the big thing you're touching that. Yeah, what is that?
It's a garbage can.
Oh God! It looks like to me. It looks like a big ass calculator or something, like a Texas Instruments like scientific calculator. That's hilarious. Well, shows you how my mind works anyway. So Sean, where are you from?
North Bay, Ontario.
Oh, another Canadian.
Yeah.
Cool. Oh, I need to change my video, don't I? Hang on a sec. Hang on, stand by. Because I'm an idiot. Hang on one sec. Just hang on. Hang on. Where are you, stupid thing? I got to get back into the scheme of things. I've had too much of a vacation here. There we go. Hey, okay.
There you are.
Hey, hi. Sorry, I was just a voice in the void. Anyway, sorry, Sean. So say again, Sean, where are you from?
North Bay, Ontario.
Cool.
Right by Sudbury, actually. I think you said you have family from there.
Oh, I did. So we have met. We have met at one point, or
I watched your videos. I think.
Oh, okay. Yeah. My mom was born there. Sudbury, Ontario, amidst the slag heaps of the nickel mining facilities, so to speak. Anyway, and so you're a game collector, I'm guessing. I see a Tempest and
yeah. I guess. I mean, my hobby is trying to fix them. Once I have them and I fix them, then I sometimes sell them. I keep the ones I like and pass on the other ones.
Are you mostly a vector guy, or do you everything?
No, more arcade, but some pinball, and I just like Tempest. But
you seem to have a really remarkably unburned in CRT there to your right. What is that?
Well, this is one actually that it's a K7000 that has a bloom kind of thing, and I did put some comments on Facebook, and you responded about.
Okay.
I kind of wasted my time, and I totally admit I did, but I'm here for help.
Okay. Okay, great. And Paul's also Canadian. Where do you live again, Paul?
I live in Florida.
No, you do not.
Yes, I do.
I thought you were Canadian.
Nope. I live in Tampa.
James Crow.
Oh, I'm thinking of James. That's right. Okay. Oh, God. Shows you how much attention I pay. Oh, there's people. Wait a minute. I got to admit people. Sorry.
You can tell you're somewhere hot because your garage door looks like it's open.
You can tell you're hot. Oh, yeah, that's right. Yep.
Oh, yeah. You're in the midst of a freezing cold, freezing nest there in Ontario, eh?
Not too bad today.
What would you consider not too bad in Ontario?
It's around 0 degrees Celsius, so 32.
30, oh, that is not too bad, actually. Not really. Anyway, cool. So, hello, everybody else. Anybody new that I haven't met? Justin, have we met? Justin?
No, haven't met. I was the one posting on the page on Facebook with the question, But no, I've heard of you, and you're a legend, but I have yet to meet you. So nice to meet you.
Hey, nice to meet you. I like your ceiling. Is that forever or just for the holiday season?
No, that's forever. My whole basement, I got Christmas lights up there. So
Oh.
so
I like it. I like it a great deal. Yeah, that's nice. And Brood Witch. Oh, that's weird. So, what's your real name and where are you from?
He's
Appreciate
still
you.
on mute.
All right. Well, okay. Don't speak to me. That's fine.
I just told him about this going on right now.
Oh, hey, Ludo. Hey, and George. Hey, hi. How are you? Everybody okay?
Yeah,
Ludo, are you there?
Good.
Hey, Randy.
Okay. So George, thank you very much for doing this, by the way. I mean, I hope it works out. I I do really appreciate it a great deal. You can tell I don't do this very much, and I don't really care. I care about you guys, but I don't really care about the social thing. Anyway, so there was a few requests there. The first one was something about convergence, and I really can't recall what the rest of them were. George, you're my moderator. Why don't you tell me what you think we should cover?
Oh boy.
Sorry to put you on the spot. Okay, John.
First, no. I got something.
Sorry,
something.
time's up. Sorry,
Okay.
you lose that. No.
Okay.
No, I'm just kidding. But I mean, I'm wide open to suggestions. I really don't have any sort of agenda here at all.
Oh,
No.
so it's
Well,
based on.
if I could throw out one suggestion,
Yeah,
somebody
okay.
actually put it in the group chat, and I was actually thinking the same question. Was when you try and find a component that's no longer available, and you're trying to find an equivalent,
Oh.
how do you normally go about sorting that one out? Because I've been in that problem. I'm in that problem now with one transistor.
I'll illustrate. That's a great question. I'll illustrate it with an example, and I'm sure that I'll start off by saying I'm sure you're not doing anything that I don't do, and that is Google the shit out of stuff. Because here's my illustration. As some of you may know, I kind of do some work for the casino industry. I publish this magazine called Slot Tech Magazine, and I have these classes that I do mostly on Indian reservations for the slot techs, and mostly really on monitor repair and power supply repair, the same kind of thing I'm doing here, although not CRTs, obviously, just LCD monitors. So I got this really cool gig from a company. I'm burning up a little time here. It's all right. I got a really cool gig from a company called Elite Gaming, and they're in Fort Worth, Texas, and they're a refurb house. They buy in bulk containers full of old slot machines, either strip them for parts, just like an automobile junkyard would do. It's exactly the same business model, or they refurbish them and send them to Peru or Chile or Slovakia or Slovenia or someplace like that. So I got this really cool, first of all, a training gig where they wanted me to do a week of training, and I did, and it was really successful. And subsequently I said, hey, I like to sit on the bench and fix stuff. Would you be interested in having me come and do this? And they did. So all of a sudden, though, I'm not real familiar with these gaming power supplies because there's just a ton of them, and they're really poorly designed. And when they wipe stuff out, they wipe out everything. Some of them. It's sorry, Ludo, but it's a brand made in Australia called SeaTech, SETEC. And I don't know why it's such a crappy design, but it is, and it wipes out stuff. So I'm finding bad parts, MOSFETs mostly, and other stuff like that. And as these power supplies are now like 10 years old or so, and I can't find a cross reference. And I look and I look and I look. I'm sorry, I can't find an OEM replacement. I can't find the actual part number. They're just not available, not for no amount of money. No how. They're just not available anywhere. So I wasted a tremendous amount of time looking for them. I must have wasted, in some cases, like an hour easily looking for this part. And so in the end, transistor substitution is the skill that you need to have. It really is. And in general, it's not that difficult. Say, George, moderator, do you think I should launch into a little bit about transistor substitution? Maybe?
I haven't encountered that a whole lot because I stick to mostly just Wells Gardner stuff, you know, and I got.
And you can always find
right
replacement parts.
Right. Like we were saying about the K7000, it's like the Chevy 350 small block of monitors.
Right. Oh, right, yeah.
So I got in my parts container, I got voltage regulators. On the floor over here, I got like a thing. It's got like 100 hots in it, right?
Oh.
Yeah.
You can still find STR 3
yes.
1 2 3s and 3 0 1 2 3s.
There is a parts supplier. I want to say he got into this about like 5 years ago. It's arcadepartsandrepair.com.
I heard of it.
Yeah, they got pretty much everything that you need. It's
That's
all
all
there.
I buy.
Paul, you're shaking your head, Paul. What's your comment?
That's who I buy my parts from. He actually sends me the parts to test, and if I give him the green light, he'll put them on his website. So
yeah.
I test them for hours, make sure. Somebody had a K7000 with a blooming problem.
Yeah.
A lot of times that's the voltage regulator.
So that surprised the heck out of me, Paul. I read that, and I would not have thought that, because the only way that could happen is if the internal impedance of that thing somehow rises, and then when the extra current draw of the brightness makes it wig out. I mean, what is it? Do we know what it does? Does it go over voltage or under?
I've tested the voltage regulators on my testing rig, and what happens is if you get a really bright screen, the voltage on the voltage regulator is supposed to be 130 volts.
Yeah.
If you get a bright screen, it'll drop to 125, 120. Then if you go to a black screen or a partially lit screen, it'll pop back up to 130. They're bad parts. That's the bottom line. If you get a good voltage regulator, it'll hold it close to 130, maybe drop to 129, 128.
Okay, well, I learned something, and that's very interesting. That's one of them new problems that's occurred in the last 20 years that that I'm not familiar with. You know, it's like anyway. Okay, cool. Other comments from anybody? Sean, hey, you're new. What was your request? Or what's your interest?
Well, I didn't officially make it beforehand, but I do have this K7000 that is, I think, blooming kind of excessively, and I have changed many parts. I tried troubleshooting, did the stuff I knew would be a problem, like the capacitors. Obviously, it changed the voltage regulator, changed the flyback a second time. Still. And
by blooming, do you mean that the entire image, the raster, gets larger and smaller?
Yes. Specifically, like I can show it to you. But
Let's see.
Yeah. I think Paul and James will probably have better input on this than I will.
Did you change the filter cap?
Oh yeah.
Wow.
You see it there?
Wow. Yeah.
I found a game called
Hey Ludo.
Son of the Revenge, I think, on Neo Geo, that has an intro that is beautiful for blooming. It literally goes, the instant coin moves a few inches because there's like flames in the background.
Well, that's why I have this one selected. It's pretty good. The King of Fighters 95.
So I don't see what you're talking about.
Can you move into the screen a little bit closer so we can see?
There he goes. Yeah.
Sorry.
I don't really see anything. Do you see anything, Randy?
I do, but he's moving the camera, so that's an issue.
Yeah, sorry.
No, see if you can hold the camera steady. Put it on something.
Yeah. With me.
Yeah, and get the edge of the monitor and the raster in one shot there. Not the whole monitor face, but the edge of the physical edge of the monitor and the edge of the raster.
And it might help if we could get a colored background too.
You're too picky. There we go. That's what I want to see. That's perfect. That's perfect right there.
I know.
Oh wow. Oh yeah. So what's interesting about this is, and I really could be wrong about this. And Paul, your input is everybody's really is warranted here. We know the issue with gun games and how they make the white flash and it causes the blooming issue. And there's this extra high voltage capacitor. So, that comes off the second anode. So, Wells Gardner, as we've written in this forum, made like 100 different monitors. They made little tweaks on those K7000s, like we're just a component value here or there. And I described, I posted it, a little cubby hole where they had 100 of these engineering samples. And I'm not kidding. The building that they used to be in Chicago, was a 75-year-old building, or no, more than that. It was like a 125-year-old building. And this little room was like underneath a chimney, sort of kind of walled in. And there were all these engineering samples. So sometimes, and I'm not saying it is in this case, but sometimes it can be just a component value or something like that. Well, all that having been said, if you've done everything that you've tried to do to resolve this issue and it's still like this, I wonder if you could find a chassis that's got the high voltage capacitor on it. I mean, is that ridiculous these days to think that you could find such a thing? Maybe so. Is there, I don't know, somebody.
I have a question.
Yeah.
He's running a Pandora's Box 6. Does that actually accept CGA signal, or do you got some type of modification to accept that signal? I thought number 6 was like a VGA.
No, it has CGA.
Oh, it does? Okay.
And I have tried other boards, even the 60 and 1, which I usually use for testing. It flashes, it goes to burger time and stuff like that.
Is your B plus stable?
Yeah, it was actually really good. Yeah.
What would your B plus?
It was, I did post it on the Facebook page, but it was like right around 123. Like
question. Sorry to interrupt you, Paul, but I will, because it's my thing. Interrupting, that is. Have you tried this source on a different monitor and it doesn't have this issue? So we're absolutely certain it's in this monitor. Or vice versa,
No, I've tried other games. Plus I have this little arcade monitor tester that's made by PCB Junkie.
Well, because it can be a matter of video levels. That is to say, if you are driving the video level, the actual amplitude, as it's called, of the video signal, the voltage of the video signal, too much, you could definitely have these weird kind of issues. What we call the front end, the video amplifier, is really looking for, it's not that narrow of a range, but it's looking for a kind of a range, and you could definitely be overdriving it with a 5-volt signal when it's really looking for kind of 4, kind of, sort of. If you turn the contrast down on this monitor, what happens?
It gets a little bit better, but it's still objectionable in my mind.
Well, do you have an oscilloscope?
I do, yeah.
Could you look at, you don't have to do it right now, but could you look at the actual video input, in the RGB input, pick one input, I don't care which one, red, green, or blue, into this monitor and show us and measure it? What is the amplitude? Is it 5 volts? Is it 4 volts? What are you actually getting into the monitor just for academic purposes?
Like this thing only is powered by a 3-volt battery, a CR 2032. So I mean, I could put this on there and it also blooms.
Oh, what do you mean? Really?
This tester, yeah.
You mean when you change from one pattern to the other?
Well, this one has a bloom test feature, so it goes from a white screen to black screen, white screen to black screen.
Oh, could we see it? Well, well, that's a nice clue. Thanks for mentioning it. Yeah, let's do that. What size is
this monitor?
Yeah. Randy, I have a quick question regarding
Ludo.
Yeah. So I've only measured video signals on an oscilloscope a couple of times, and it was always recommended to use a full wide screen. The purpose was to look at the maximum video output. So in that case, it was, SCAD 75 ohm, so 0.7 volt peak to peak, right?
Exactly.
So you have to feed a wide test. In in your purpose here, what would you be looking for? Because especially when you have like a, let's say, a game menu like he had on the Pandora, you don't know if it's maximum brightness or halfway. So what it's kind of not, I mean, of course with a wide screen it's precise, but with a random game signal, what would you be looking for, or how do you work around that with the game boards that don't have a wide screen?
Yeah, that's a good question, and honestly, video is for me the most fun thing that I can look at with an oscilloscope. I just love looking at the video, the actual video signal with the scope. It's really interesting how it worked, and it really, when I first started working on video games way back when, it's what really opened my eyes to what the heck was actually going on. So let's just kind of look at a standard kind of video, and we really don't have a standard if you've been following my thread as we talked about before. Let's do it this way. You know, it's a standard oscilloscope graph that shows time in the horizontal direction versus voltage in the vertical direction. And in this case, we never go negative. So there's ground right there. I'm getting a weird feedback. If somebody could mute yourself or something, I'm not sure what's going on there. Remember that we've talked about this before. At the actual CRT itself, the lower the voltage is on the cathode, the more the electrons come out. But that's not what we have here. What we have here is very simple. The higher the voltage, the brighter that color is. Now, Ludo just mentioned 0.7 of a volt, 0.710 into what's known as 75 ohms impedance, and we're not going to really talk about that, but about 0.7 volts or so. That's not the standard that everybody else that collects games is used to, where the red, green, and blue signals come into the connector, you know, the 6-pin connector, RGB, ground, vertical and horizontal positive sync, right? These signals, they're really looking for anywhere from, I kind of want to say 0 volts, but at 0 volts, it will be completely off, as you can imagine. So they're kind of looking for something from about 1 volt, which is dim as dim can be, to really about 4 volts. Yes, some games shoot 5 to it. I don't think that would be an issue. It shouldn't be. It shouldn't be more than that for sure. But typically, you know, 1 volt is barely visible, super dim. 4 volts is as bright as it can be. And if it's over 4 volts, now you're overdriving it. The audio equivalent would be, you would have clipping, you would have distortion if this was an audio amplifier and you were to overdrive it. But it's a video amplifier, and so it causes the video amplifier circuit to sort of what we call saturate, like, you know, really turn on as much as it can be, and you don't want that anyway. So we have 2 standards that we're really looking at here. The one Ludo just mentioned, which is from 0 volts to 0.710 volts, and then this other kind of standard, which is from 0 volts up to 4 volts or so. So the higher the voltage, the brighter it is. If you were, for example, to look at color bars that show, you know, the red, green, and blue color bars, that's full on each color one at a time. Well, we're only going to look at one color at a time, red, green, or blue, so we don't really need the color bars. And what Ludo is saying is, do we want to check it on full on, you know, maximum color, which would give us this. That is to say, whoops, sorry. Well, let me do the 0.7 since Ludo mentioned it. So, and that's what's known as the SCART connector, is 0.710. Anyway, so remember we're looking at time in this direction. So, here there's like no video, and then we want something to be really bright. The video simply jumped up to 0.7 of a volt or so. And then at the end of each line, that video is dropped down to 0 volts. Remember, that's the blanking period. Remember that there's a blanking period there where we want all the guns to be off. Well, yes, the monitor has its own blanking circuit, but why would we turn on all the guns during the blanking period when we can just as easily turn them off just by making the video signal drop to 0 volts like that? So that's what one line is. Personally, that's not, for me, that's not very interesting. I'd kind of like to see it do things. So when I put it on the color bars and it looks something like this, now I see a video signal that I can clearly see. Here's where it's really bright, and here's where it's off, and here's where it's bright. So I like to see that. And what's really fascinating, I come from a consumer television repair background, is looking at what real video looks like. If you look at PAL video or NTSC video, and you see how the actual brightness and darkness of the image that you're looking at varies, that's super interesting. So anyway, that would be one line. That would be one line, meaning that from here to here is approximately 50 microseconds there. But let's say we wanted to look at the whole field, remember, one pass of the beam from the top of the bottom to the screen is called a field. The field, that's one line of video. The field would look something like this, where let's say we have negative sync here. I guess it doesn't matter. So let me think about how I'm going to do this here. Yeah. So here is one field, like here, and this is approximately, I think, 14 milliseconds. This time period from here to here is like 14 milliseconds. It's the amount of time that it takes the beam to travel from the top of the screen down to the bottom of the screen. I think it's about 14, because there's like 1.3 milliseconds of retrace time that it goes back up. Anyway, I could be a little bit wrong about that. But during that time, oops, I shouldn't have erased that. During that time, remember that the beam has gone back and forth 240 times during that time for kind of standard NTSC video. So that field, as it's called, which is this time from here to here, is now serrated with 256 horizontal sync pulses. I'm not going to draw 256 lines in here, but if I were to expand this out, you would see that these are this is the horizontal retrace time, but there's 256 of those. So that's another interesting waveform to look at. The amplitude is still the same. It's just we're just looking at a different part of the waveform. So that's what I would expect to see. And then the sync pulses, of course, are TTL level. The sync pulses are either positive sync, going from 0 volts up to 5 volts, as you know, and back down again, making a sync pulse that's positive, or negative sync, which also, as you know, starts out as 5 volts, drops to 0 volts when it wants to synchronize the monitor, and jumps back up to 5 volts, making a pulse that we call it negative sync. It is not negative voltage. It goes from 0 volts, from 5 volts down to 0 and back up again. It's not negative voltage, but we call it negative sync because it goes down and positive sync goes up. So Ludo, does that make sense? Is that what you were looking for?
Yeah, and I guess what kind of voltage were you looking for in asking Sean to put a scope on that particular game screen? That's kind of what I was after. Since it's we don't expect if it we don't know if it's a full wide or not full wide. What kind of wave were you looking for in what you've asked to Sean?
it wasn't so much the waveform I was looking for as the amplitude, the voltage of it. Is this crazy thing that this Pandora, I think Paul said it was, is it putting out is it putting out 6 volts or something weird like that? I don't know.
Right.
I don't know what it's putting out.
So based on what you said about 1 to 4 volts, you were looking for something around 2, 5, 3 to be normal, and if it was outside of that, it would have been something weird.
Precisely so. I'm just gathering data. That's all. I'm not diagnosing anything. I'm just gathering data, which is the fun part, in my opinion, the fun part about being a technician. The most fun and interesting part about being a technician is not performing the repair or even seeing the thing work, which I admit is nice. It's the detective work, I think, and that's just me, but it's what? Let me gather this data and figure out what I got. I mean, I guess I being an ex-Boy Scout, I equate this to survival training, where the first thing you do is dump out your rucksack and look and see what your resources are. You could walk around with a pocket knife that you never knew you had, so I'm just gathering data. That's, as a technician, that's all I'm doing, if I don't mean to pontificate.
Thank you, and sorry, Sean, for hijacking your topic.
Ludo, you're always welcome.
Can I say something?
Yeah, please. Yeah, you're the moderator. You have control.
I think it's IC2. Is that where the video signal goes through on the K7000? It's IC2.
IC1.
IC1, yeah.
Is it IC1? Okay.
Oh, yeah.
I don't even remember the part number on that now. I haven't had to replace any one of those because they're bad.
No, that IC never. It doesn't work very hard. I've never replaced IC1.
But
Paul, maybe you have. I don't know.
Would that have anything to do with this?
I can't imagine. On the other hand, is it possible something deteriorated around IC1?
Well,
yeah.
There was a guy on KLOV, this is probably a couple weeks ago. He said that he was having random color pixels show up on the screen. And, I was part of the discussion. I was just throwing out a bunch of stuff, check this, that, blah, 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 right? And what wound up fixing it was replacing IC2. So, yeah.
Do you think he described the symptom incorrectly?
Well, a lot of them, yeah. Here's the issue now. There's a lot of people that are about my age. They're just getting into buying games for the first time. Oh. They don't really have the grasp on the basic understanding of how stuff works. So when I join in these discussions, I'm not just going to tell them replace that transistor or replace that cap or whatever. I'm going to go into why it failed, why you're replacing it, and any other potential things that could be affected by it. So for whatever reason, part of that discussion we arrived at, well, I guess it's IC2. The guy replaced IC2. I'm sure he bought it from arcadepartsandrepair.com. And
the link is included in the description below.
And that fixed it. But going back to the original point, a lot of people, they'll just say oh, the picture's washed out. And I'm like, okay, your definition of what you think is washed out, I mean, that could be 800 different things.
Yeah.
And they'll create monitor threads and they won't even have pictures of what's going on. So it's I'm not going based on your words, no offense or anything, but
well, that's the role that you have undertaken as a volunteer tutor, I guess you'd say.
Yeah.
So Sean, do you have a scope on this now?
Yes, I do.
Well, and so what's the amplitude? What is the voltage?
It's about 2.3 volts.
Oh.
Peak.
What? Well, that ain't the problem.
That's other. Do you want to see the blooming on this one, or can you see it from there?
Yeah. Sure. Yes. Could you put zoom in a little bit on it?
Okay, so I'll try not to.
On the corner, maybe.
Yeah, on the corner. Be great. There we go. Oh yeah. Wow. Oh, wait a minute. Is that how it's framed, or is that blooming? I do see a little jump there.
That's massive.
Yeah, like, and also my convergence is off. I changed the yoke, but yeah, this should be the same. Like, this line is supposed to be in the same spot.
This is the 19-inch monitor, right?
Correct.
So does the 123 volts stay at 123 when it does this?
I think when I have it on,
No
I can
way.
measure it right now, but it was, measure it. Yeah.
You could also measure, you could give us one of the flyback derived power supplies, like the 12-volt supply. If you could pick off that someplace and show us that, does it go from 12 to 12 and a half? That would tell us what the actual high voltage itself is doing. But I also want to throw another idea out just out of curiosity. You did say you replaced the filter capacitor. Do you have the old one still by any chance?
Yes, I do. Yeah.
I wonder what would happen if you put it in parallel with the one. I'm not saying to modify things. I'm just curious. What would happen if you put that in parallel? Would that change anything? I wonder. That's not for right now, but that would be something to do in the future, where you would just solder it in, just tack it in with a couple of wires, and just see, does it change any?
Regarding the B plus measurement of 123, would a multimeter be fast enough to monitor any fluctuances, or do we need to use the scope?
Oh yes. Oh, you absolutely could see it, Ludo. Absolutely.
Yeah. Okay. Gotcha. Thank you.
Yeah. Yeah. And again, I guess you're really looking at two different things here. One is to check the B plus output of the voltage regulator, and the other is to really look at the output of the flyback transformer by looking at one of these DC supplies, in this case, either the 12-volt supply or the 24-volt supply that comes off the flyback, unless you have a high voltage probe. If you have a high voltage probe, look at the high voltage and see that it's dropping and increasing. Let's see, kind of what's going on there. But the alternative, much safer method is to just check the 12-volt output and see if it's hopping up and down. And again, I'm only gathering data. I'm not saying that points to anything specific.
Is that?
So it fluctuates 0.7. There's a 0.7 volt.
Yeah, that's okay.
I missed it. What was that? The 100, the B plus? Oh, there it is. Okay.
123.5, 124.2.
Well, it's 1%. I guess that's reasonable, huh? Yeah.
Paul, you were saying 123 is not good for that chassis?
123 is perfect. I didn't know it was a 19-inch. It's optimal is 123 for a 19-inch chassis, 19-inch monitor.
Hence the part number STR 30123 or 3123. So wow. This is very interesting.
I got a question.
Now, all this having been said, let me just insert something. This is nothing that I, as a professional operator of games, would ever worry about in a million years. I would look at that and say, this monitor's working fine. It blooms a little bit. Put it out. Let's go. Put it out on the route. Not a problem. So I'm just wondering if we're chasing a problem that is an engineering issue. I know they don't all do it, but
this is very pronounced, right, Randy? But I've seen it on Neneo MS9s as well, MS929.
Yeah.
And same as what you said. Some people say, well, that's fine. That's per design. So how often do you?
Well, I wouldn't say it's by design, but I would say,
exactly. That's not an actual monitor fault. Yeah.
Well, that's like I've swapped out IC1, I've swapped out IC2, I did a whole full cap kit.
Well, you did the flyback and all. I mean, the only thing that you haven't changed is all of the retrace tuning capacitors, the things that look like big pieces of Chiclets chewing gum. I'm not looking at the schematic.
The green ones?
Yeah, I don't know if they're green or not. The 0.039 at 400 volts, the kilovolt capacitors, 1.5 kilovolt that are in the horizontal output circuit, all those, the S-shaping capacitor, as it's called, all those guys. Their failure is typically catastrophic. When they fail, they burn up. So in fact, I've never
blow the fuse too.
Yeah, sure. So I've never not seen that happen. But anything's possible with stuff you're working on is so old. It's so old. You know.
You don't happen to have a high voltage probe, do you?
I do. Yeah.
Oh.
Well, that's great. We can see what the high voltage is.
So next time we do this, Sean, you'll say, "Hey, Randy, I have a high voltage probe and a pattern generator, and maybe we can use those things."
You didn't ask the right questions.
I know I didn't. It's my fault. It's my fault.
I asked the right question. Thank you.
Yes, you did, Paul. Yes, you did. Oh, he's a man with a plan. Look, he's done this before.
I got the same one.
It's great that this little pattern generator does this. I think that's a neat blooming test. I've never seen that on a pattern generator. It's great.
Yeah.
It's fabulous.
Does it do anything else besides that?
Oh, must do full patterns.
Rolling bars and crosshatch and stuff.
I like to get one of those.
It was
Yeah.
inexpensive too. So
Maybe you could type it in the chat or something when you have a chance.
I will. I'm going between 28 or 27 and a half to 28 and a half kV.
Oh, that's very well regulated. That's weird. I guess it could make a difference, but wow. Yeah, don't know. Sorry, I totally admit defeat.
Out of curiosity, when you put that test pattern generator on another monitor, it stays in the same frame. It doesn't bloom.
I tried it on my LCD monitor, so that's not really a good comparison, I guess. But in the LCD monitor, it did.
I think you'll find that they all will do it to some extent, but that what you showed us, that's pretty dramatic.
It is dramatic. It is dramatic.
Randy, question about this.
Yeah.
It's curious that when you get a full white screen, it gets bigger, but when you get the black background, it gets smaller then. Shouldn't that be the opposite if it's a voltage regulator problem or a regulation problem?
It really comes down to the high voltage and sucking the electrons out. When you see blooming, what it really is that as maybe I should go to the board. Give me a second. Although we had this discussion previously, but let me just switch cameras. Hang on one sec. Stand by, please. Stand by.
Ooh, I like that.
Yeah, so far so good. I just got it a month ago. So.
Oh yeah. Oh, why do they move? Oh, that's kind of weird. I'm not sure what benefit that is.
Where did you get this from? Where'd you get this generator from?
PCB Junkie. It's a Canadian guy, I think. But it's like as the test pattern generator, right? When you pay taxes and you bring it across the border and the duty and everything, it's pretty expensive. So
how much does it go for?
I think it was like $40 Canadian.
Ooh, that's free, American.
I was just gonna say that's like what, $2?
Yeah, that's right. and 50 cents. So the deal is it has to do with the number of electrons that remain. That is to say, remember that the second anode, which is connected to the, as we call it in Merck, the integrated high voltage transformer, that's its actual name, IHVT, in that it is a flyback integrated with high voltage diodes and the potentiometers and all that kind of jazz. So remember that this is touching the aquadag, AQUADAG, that's painted on the inside of the glass of the CRT. So when you are connecting to the second anode, ANODE, you're specifically connecting to the whole inside of the picture tube. So we have these three electron guns that are shooting out this stream of electrons. And like this, well, if the high voltage is not sufficient, some of those electrons will remain inside the bell of the CRT, inside the fat part of the CRT. And as the electron beam comes out, can somebody mute themselves? I'm getting some weird feedback. Everybody mute themselves. As the as the electrons shoot out of the electron gun, they will be deflected. That's better. Thank you, whoever just did that. They will be deflected by this negatively charged cloud. Remember that similar charges repel each other. So I have this negatively charged beam trying to come out. And if it is bright, that beam is deflected out to the edges, which sort of reinforces this myth that the high voltage is there to suck the electrons toward the front. That doesn't make any sense in this regard. If that's the symptom, this must be the kind of the way it actually functions. Does that make sense? Does that answer your question? Or not? Did I misunderstand your question?
Can I ask a question?
Yeah.
I want to say it was your monitor repair DVD that I was watching like years ago. Am I correct in understanding that the electron guns in the neck are shooting electrons at the face of the tube, which is, where your second anode is connected, coming out?
No. So let me stop you there. Second anode is not connected to the face of the picture tube at all. The second anode is connected to the aquadag that coats the inside.
But
it's not connected to the screen.
Is the flyback outputting protons? I guess is the question that I'm asking.
No, you can't move protons. This is electronics.
Okay.
It's not protonics. To move protons, you kind of have to have a cyclotron. You have to have like a Fermi lab, atom smasher, that kind of a thing.
I was just wondering if like the emissions from the electron guns, like science, you need like protons and electrons to touch, right? Mm-hmm. I thought that's what it was. I interpreted that wrong, I guess.
Well, here's what you may be thinking of, and this is perfectly great way to think of it. There's two ways you can kind of think of electronics, and one is called electron current, which is the way the electrons themselves really move, and that's kind of what we're talking about here. An electron, a negatively charged subatomic particle, is physically moving from here to here and whacking against the front of the screen. But the other way is something that we refer to as Hole flow. That is to say, electron comes off of an atom. What's left is positively charged, like you said, like protons and stuff like that. Isn't moving an electron one way kind of the same as moving a hole, that is an atom that's missing an electron, the opposite direction? And the answer is it is, sort of, in a well, not even sort of, kind of in a real way. And in fact, in terms of the way the schematic diagrams are drawn, they are drawn not with electron current in mind, but with hole flow in mind, where the electric current flows from positive at the top of the schematic down to ground or negative at the bottom of the schematic. And that's the way it works. So I can see what you're saying. And you're not totally incorrect. Not really, but it's not protons.
Okay.
It's the inverse of an electron, only in a conceptual way, but not in a real world kind of a way. More questions? No?
Oh.
Are we changing topics, I'm assuming? Then?
Yeah, your choice, sir.
Okay. I do have a topic.
Okay.
All right. So this might not be very interesting to a lot of you, but this is regarding the degaussing circuit.
No.
I know there's not much to it, but I have a couple questions because, believe it or not, I actually have a TV on which degaussing failed. And I thought, surely I should be able to fix it. I changed the PTC with a PTC from a similar chassis. I looked at the circuit. I have the schematics. I changed another cap that seemed to be, in that area, and it still doesn't work. Now, I haven't done any measurements, but I guess as a theory and as best practices, I have a couple questions. Okay. So one is,
are the PTCs interchangeable across all chassis, or if not, what do we look at?
That's a good question. I've never had one fail. But I guess now that they're older, maybe that they do open circuit. I'm certain when they fail. Well, let's think about it for a second. Surely the degaussing coil itself has to be roughly the same resistance, the same actual resistance, and they'll
Even
all be
across sizes.
Well, let's think about it for just a second, because they're powered by either 120 volts or 240 volts AC. I guess in your case, you always use a 2-to-1 step down. Are they always powered by 120 volts where you are in the world?
Those are consumer TV, so it's 240.
So it's 240. So in that regard, no, they wouldn't be. Certainly a PTC from a 240 set would not be the same as a 120.
Right.
But I just can't imagine that it's that much difference. I guess the result would be either you'd burn the darn thing up, or it would be ineffectual, I suppose, would be the two things. But it's easy enough to measure the cold resistance, isn't it? And the way you can test a thermistor, of course, is measure its cold resistance and heat it up with a hairdryer or something and watch its resistance change. PTC, it'll go up, and NTC, it'll go down, right? And is everybody aware? Yeah, so that's PTC, positive temperature coefficient, right? Is everybody aware of what we're talking about? Okay, good.
I've never had one go bad.
Never had one go bad.
No.
Never.
Yeah,
never.
if I've never seen it go bad and I've never actually fixed it, chances are I probably don't have much to contribute to the discussion.
But Ludo, I mean, they do get hot, and I certainly have seen bad solder joints on them. It's never been the actual device that's been bad. Have you not done any sort of continuity test on this at all?
Not really. So I took it off circuit. I measured it. It was the same as the replacement. I reflowed all the joints.
Yeah.
But I haven't done any voltage measurement. I'm still pretty scared. I'm not as advanced as you guys. I had pretty bad experiences trying to measure mains and high voltage on the live chassis. So
good.
Yeah.
I'm glad you're scared. Stay scared.
Yeah, scared has been good. It's good, right?
The high voltage doesn't bother me at all. The EHT on the CRT doesn't bother me at all. But I've gotten straight across your 240 volt mains once in my life when I worked in London. I worked for a game distributor there. And someone there had put together a bunch of bootleg video games. It was a Grand Track 10, very first sort of God's eye view black and white video game. And, on the older games, not anymore, not for years, there was a coin lockout coil. Do you know what I'm talking about? If you de-energize the game, if it was unplugged, an armature plate would disengage from an electromagnet. And if someone dropped a coin in, it would return the coin. So that's on the coin door. So obviously you would be a moron not to wire anything there but 12 volts maybe, because it would be highly dangerous. So somebody in building this cabinet decided to put 240 volts there across this coin lockout coil on the coin door. Well, I work on these all the time. It's 12 volts, no problem. I'll just grab the two like this, like one here to pull it off. I mean, it was really intense. I mean, I barely was able to let go and sit down for about 15 minutes. That was just crazy. So I understand your reticence, Ludo, but what you really need to do is, you could do this safely with the power off. Just check continuity from one side of the AC plug. Just follow the traces on the bottom of the board where it goes through the PTC thermistor and around, and see where you're missing it. It has to be either a tiny fracture in the printed circuit board of the trace, or a bad solder joint, or something like that. I mean, what else could it be? It's not logical that it could be anything else. I mean, unless the coil itself is disconnected, which you could easily check with a meter, and I don't know what it should be. I don't know. What do you think, Paul? How many ohms is a degaussing coil? 6 ohms? Less? Whoops.
You're on mute, Paul.
There you go. Muted, Paul.
Measured
better
them, and
handle
they're
of that mute button,
usually
Paul.
between 6 and 8 ohms.
Sorry, how many ohms?
Usually between 6 and 8 ohms.
Is it?
Usually is
Okay.
normal.
Okay. So, you know, just obviously you would want to check the resistance of that coil.
I'll try that as well. I had, yeah, it's a bit of a mystique around those circuits, and I know there's nothing to it, but I had two very weird things happen to me on consumer TVs. One was I forgot to have the coil plugged into the chassis, and I had a resistor starting smoking. So I turned off the set, I put it back, and then no more smoke. And the second one, I think I was also trying to repair, that was years ago, degaussing not working, and I changed something. I think I replaced with another thermistor off the shelf, and I had the degaussing coil start bubbling up. Like the tape would start bubbling up. So, you know, that's why I'm careful now.
Yeah, that's if you're not going through the thermistor. If somehow you've managed to hook the mains directly to the coil, it'll do that in 1 second. It'll start to bubble up.
Right, so it was continuously feeding 240 through the coil, right?
Exactly, precisely so. Yeah, and in any case, it's, you know, it's intermittent duty. Even if you've had an external degaussing coil, you know that it's 30 seconds on, 2 minutes off, or 4 minutes off, or something like that. It's an intermittent duty device.
I had one fail in a 4900 once. That was a very odd failure for the degaussing circuit. You'd flip the game on, and you get a horizontal line from the bottom, and it would just slowly scroll up through the screen and start at the bottom again and scroll up through the screen. And I've never seen that before. I was like, what the heck is this?
And what was it?
For some reason, it was the degausser. I unplugged it and it just went away. It was the weirdest thing I've ever seen. They fail in some odd way sometimes. It was just a very slow scrolling line right through the screen.
Wow, I can't even imagine. Unless, well, I won't speculate. Oh, wait, there's someone in the waiting room. How do I do this? How do I emit him? It's the Zan Man. How do I Zan Man to admit? There you are. How do I Zan admit? There you are. The Zan Man. Okay, so next, I guess.
If we could go back, sorry, to the question I asked earlier about finding replacement parts. I appreciate the plug for arcade repair. Sometimes it takes a while to get things cross border up here in Canada. Could you go a little bit more into detail, like you were mentioning with transistors, about what you look for when comparing to find something?
Sure. Yeah. I threw it out there, nobody responded, so I moved on. So yeah, sure. And it's really important. I think it should be talked about. So hang on. Let's go there and there. Okay, am I on? Yes. All right. So we need to talk about I guess we should talk about two different kinds of transistors, but you guys are only dealing with bipolar junction transistors and not really MOSFETs so much, not really in your older stuff. So let's look at those. So let's kind of just take one little, am I on? Everybody okay? Cool.
Yep.
All right. Let's just take a little bit of a step back and talk about the diode for just a sec here. And then we'll move on. So diode, as you know, is a one-way gate for electric current, and it only allows the electric current to flow in one direction like that. And remember that there are two specifications for the diode. And again, I need somebody to mute themselves. Everybody mute themselves, because I'm getting some weird feedback here and it's driving me nuts. Yes, thank you. So diode has two specifications, as you know. Very simple. They're rated by voltage and they're rated by current. So the voltage rating is, as you know, the maximum amount of voltage that the diode can block. It's the maximum amount of voltage that the diode can block. Now, the diode will allow current to flow in this direction, but it will block the current from flowing in the opposite direction. Well, we have names for these two operating modes of the diode. When the diode is conducting and electric current is flowing through it just the way the arrow is pointing, we say that that diode is forward biased, B-I-A-S-E-D, forward biased. This word biased, B-I-A-S, is just sort of a fancy word for putting a voltage on something. It's called biasing. So when the diode is conducting, we say it's forward biased. In other words, it is on, let's say it's conducting. When the diode is blocking the current, in other words, the current wants to flow opposite the way the arrow points, it's blocked. We say that the diode is reversed, or it's reverse biased, B-I-A-S-E-D, reverse biased, meaning that it's off, it's not conducting. So we have a name for this voltage rating of the diode. The voltage rating of a diode isn't just called the voltage rating. It's known as the diode's PRV, which stands for peak, meaning maximum, peak, I screwed myself there. It stands for peak reverse voltage. It's called peak reverse voltage, or PRV for short. So that's the voltage rating for the diode. And with the diode specifications, you can always use a diode of a higher PRV. You can always go up in voltage rating of a diode. It's just how much it'll block. If you need a diode that'll block 100 volts, but you stick a 400 volt diode in there, that's okay. So anyway, so it's called the PRV. On the other hand, the other specification, the current rating of the diode, is the maximum amount that it will pass through itself. It's the maximum amount of current in amps that it will pass through itself when it is forward biased. That is, when it's turned on and current's flowing through it, how much current can flow through it? 1 amp, 2 amps, 10 amps, how many amps? So so that's known as the current rating of the diode is known as I sub O. So I is our word for our abbreviation for current, as you probably know, because early pioneers in electronics thought of current as intensity. So we don't use C for current, we use I, which is weird, but anyway, it is. And then it's got this little letter O here, and I think I've mentioned this before, that this is in one of these workshops, that this is known as a subscript. I sub O is how it would be pronounced. I sub O. And the subscript further describes what we mean by the big letter. In other words, I for current. What kind of current? We're talking about output current here. So I sub O. So those are the two specifications for a diode, voltage and current. And you can always go up in voltage, or you can go up in current, or both. So the only other specification you have to be concerned about sometimes, not often, but sometimes, is the speed of the diode. In monitors and some power supplies, switching supplies, there are some diodes that are high-speed diodes. They're sometimes known as fast recovery diodes. It might be known as a fast recovery diode. And in some of the older gear you guys work on, you might see a part number like FR103, fast recovery 103. So it's not the familiar JEDEC number we're familiar with, like the 1N4004, which is a common diode that you're probably familiar with already. It's a fast recovery diode. It's a high-speed diode. If a high-speed diode came out, a high-speed diode has to go back in. You'll see these in the horizontal output circuit of a monitor. You'll see that these are fast recovery diodes. And for example, I mentioned earlier in this program, the flyback derived power supplies, the 12-volt supply and the 24-volt supply that come off the flyback transformer, that would also have to be a fast recovery diode because the frequency of operation there is 15,750 hertz, and a normal diode maybe works off of 60, of course, but maybe 400 hertz or something, but certainly not 30, not 15,000, not. So anyway, so the three considerations, and I'll move on to transistors momentarily, are voltage rating, same or higher, current rating, same or higher, and I'm talking about substitution, of course, and the speed. It's funny, I've never tried putting in a high-speed diode where a regular diode goes. I know you can't go the other way around for sure. I would imagine that it probably wouldn't hurt too much, but you should be aware that the fast recovery diode has a lower forward junction drop, which in most of our applications shouldn't make a difference. But you know how a normal diode is like 0.560 or something one direction and open the other way. Don't be surprised when you're checking a fast recovery diode. It might be 0.35. It might be 0.15. I mean, it can be really low as long as it's open the other direction. We call that the front to back ratio. As long as it's open the other direction, it's a good diode. Anyway, so is everybody with me so far? Any questions so far? Cool. All right. So let's move on to transistors. And it's almost exactly the same with one little wrinkle. So transistor specs, transistor specifications. Like the diode, well, sorry, let me draw the schematic symbol here for the transistor. And this is not a whole discussion of transistor theory. This is only specifications and substitution. But just to remind you, the three legs of the transistor are known as the emitter, as you know, the lead with the arrow on it. The lead on the same side as the emitter without the arrow is called the collector. And the controlling element, remember, is referred to as the base. So it's sort of the same exact thing, where one of the specifications is the voltage rating of the transistor. However, there are a bunch of different voltage ratings for transistors, but there's only one that we really care about. And remember how the diode has a weird name for the voltage rating? It was called the peak reverse voltage. This has a really weird name. The voltage rating for a transistor that we care about is called V sub CEO. V for voltage, obviously, and the subscript, the sub CEO here. What this means is that this is the maximum voltage that the transistor can handle between the collector, that's the C, and the emitter, that's the E. And that's the main switchy part of a transistor, as you hopefully know, between collector and emitter, with the base open, meaning disconnected, is what that actual O actually means. So when the base is disconnected, the transistor is off, because that's the controlling element. We have to put juice on the base to turn it on. So that's when it's really blocking the current flow. Though when the transistor is blocking the current flow is when it's turned off. So this is the main specification that you are interested in a normal bipolar junction transistor, BJT as it's called, normal transistor, V sub CEO. There are other voltage ratings. There's, for example, V sub CBO. That's voltage between the collector and the base with the emitter open. And there's V sub EBO, which is the emitter to base voltage, but we don't care about that. The engineers, I think that they care about that, but we don't care about that. So that's the voltage rating, and you can always use one of a higher voltage rating. You can always use a transistor of a higher voltage rating, doesn't matter how high it is typically, no problem whatsoever. So that's specification number 1. Specification number 2, again, just like the diode, is the with me, everybody.
Where?
Hello,
Come here, Fonzie.
Zanman. Hey, buddy, you got a dog there or something? Here, Pooch. Come on, Pooch. Anyway, so the second specification, remember, is the current rating, just like the diode. And the current rating is known as I. Remember, that's what current is abbreviated with I. And the subscript is the letter C, I sub C. That's the collector current. In a transistor, the main current flow, like this transistor, is in the collector and out the emitter. Notice it follows the arrow when we're talking about what we call conventional current, the way the schematic is drawn. So that's called the collector current. That's the main switchy part of a transistor. That's where the main current flow is. And so it's the same kind of thing. It's perfectly okay to have a higher collector current. In other words, if the transistor, I look at the specs of the transistor I pull out, and it's a 100 volt 5 amp transistor, I can replace it with a 120 volt 8 amp transistor, no problem. One or the other, or both even. However, there's one more tricky little thing. So wake up, wake up, wake up. So this is, I'm now getting into kind of a little more advanced transistor theory, kind of, sort of, but not that much. So, so the other specification that you have to be aware of is something that is known as H sub FE. And what's weird about this is that it's actually a lowercase h, which is large in physical size, and the subscripts are capitalized FE. And I really don't know exactly what this stands for. I've read a bunch of things about what people think that this stands for. They can't all be correct, and I don't care because I know what it is. And what H sub FE is a measurement of something known as the gain of the transistor, or more correctly, it's really known as the current gain of the transistor. It's called the current gain of the transistor. It is also known as the beta of the transistor. It's called the beta, you know, the second letter in the Greek alphabet, you know, beta. All right. So here's the deal.
Doing.
And what? Everybody okay? George, you okay?
All right.
Well, you look distracted. You all right? Oh, there he goes. Hey, hi. You look unhappy, George. Are you okay? George? He's frustrated. Oh, there. I don't care what your problem is now. You're laughing. So here we go.
Oh, right. My wife was leaving. I was like, what are you doing?
Well, not like forever and ever.
No.
Okay.
No, apparently she's going to babysit for
you and your damn hobby. I'm out of here, George. All right. Anyway, so let's get back to this. So it's known as the current gain, or I should say not of, or the beta of the transistor. And what it is sort of a measurement of how sensitive the transistor is. It's sort of a measurement of, and I'm really simplifying this. It's sort of its ability to amplify. And before I go into this whole discussion, let me just reassure you that here's the bottom line. When it comes to substituting transistors, the voltage V sub CEO should be the same or higher. I sub C should be the same or higher, but you're going to want to sort of get close on the gain. You want to try to match the gain. So that's where we're going with this thing. Here's the deal. The gain of a transistor is a gain factor. For example, a transistor, I guess probably one that you're familiar with, a 2N3055 transistor that is on all the older power supplies. I think if memory serves me correctly, its gain is around 50 to 70. I think it's 30 to 70 or something. Let's just call it 50. It has a gain of 50. Now, that is not 50 volts or ohms or amps or anything like that. It's just a gain factor. There's no like person associated with this thing. It's just a gain factor.
No units?
So, no units. If you need a unit, we could call this the Elvis if you want. Like this would be a 50 LVI transistor, let's say. So H sub FE is 50. What that means is really this, and screw on your thinking cap if you can get this. If you can't get it, don't worry about it. The way a transistor really works is that it's a current operated device. That is to say, the more collector current that you have, the higher I sub C is in amps, the more base current it takes to drive the thing. If the load is bigger, we have to put more current into the base. The voltage really doesn't change. It's like, 0.6 or whatever it takes to turn it on, but it's the amount of current that has to increase if we increase the load coming out here. It happens to be called, you don't have to know this, the reverse transfer characteristics of bipolar junction transistors. And what that means is that if I put a bigger load on here, if this load varies, the amount of current that the transistor is going to draw through the base will also vary. So if the thing has a gain of 50, and let's just say that there is 1 amp of current, I sub C equals 1. I sub C equals 1 amp. It would only take 1/50th of an amp to drive it. In other words, the higher this number is, the higher the gain factor, the more sensitive it is. If this one happened to have a transistor, happened to have a gain of 100 LVI, then it would only take 10 milliamps. It would only take 1/100th of an amp on the base to drive it. If this thing had a gain of 1,000, and they actually don't make a transistor that's a regular transistor with a gain of 1,000, but let's say they did, it would only take 1 milliamp. It would only take 1,000th of an amp. They make a Darlington transistor that does that. But anyway, so those are the 3 specifications. So you really want to try to match the gain, but it's not that critical. In other words, if the transistor that came out had a gain of 70, but the one I'm putting in has a gain of 100, that's way okay. That for our applications, that is not going to be an issue. I couldn't really tell you one way or another where, like how percentage-wise, how much you could vary it, but you can get away with murder in our industry. And our industry is very forgiving. The circuits that we use are not particularly picky, not in general anyway. So does that make sense, James?
No, that was a great explanation. Thank you very much.
Oh, you're welcome. Next victim.
Is there a transistor you would recommend that we buy and stock up on that would cover most of our applications that we would need? Or like I'm talking about a single transistor that would
like
cover all those.
2SC1398 kind of a thing, but would use for anything? Nah, not really. I mean, in general, a horizontal output transistor is a horizontal output transistor is a horizontal output transistor. And of course, they have a built-in diode as well that you have to be aware of. But that's not really true because the bigger the screen, obviously, the beefier the horizontal output transistor is going to have to be. So, offhand, I would say no. I mean, I usually just always have carried 6 different kinds. I don't know, Paul, you have them. What do you carry? How many different flavors of HOTs do you carry?
For my uses, I have about probably 6 to 10 different ones.
Yeah.
I use a lot of the SD 1398s for the K7000s.
Uh-huh.
They work on both the 25, 19, and 13-inch K7000s. I'm running out of bottle cap transistors, so they're starting to get kind of rare.
I wish you guys wouldn't call them
2SD 870, 869s.
It's a transistor in a TO3 package. Stop calling them bottle cap transistors.
That's what I learned to call them.
That ain't what they is. If you go to any electronics store and you say, "Hey, Mr. Electronics Man, could you sell me a bottle cap transistor?" He's going to point to the door and he's going to go, "See ya. See you later. Bye." Anyway. Anything else?
So machines outside.
Paul, your bandwidth, your network bandwidth is very low. You're all pingy and weird.
Is it? They're probably restricting me now because I've been online for so long with you guys. Oh. Can you tell how low? Am I getting choppy?
Yeah, you're real choppy and the compression's high.
Am I choppy, guys?
Oh yeah.
Hey Randy, I have a question.
Yeah.
I just have this Wells Gardner.
Hi John.
Hi, how you doing? I've got a Wells Gardner 5515 medium or medium res, and I bought it. The tube was busted, so I found a colored TV. I'm gonna swap the tube with. I powered it on. I put new caps in it and some resistors that were out of whack, and did my best to get it ready and powered it up and automatically blew the fuse. So I got to use the light bulb trick for the first time. So I soldered in a light bulb into the fuse and where the fuse would be, and powered it on. The light went bright, and I took the long way around. I had no high voltage, nothing, obviously. I should have went to the high output transistor. However,
horizontal output transistor.
I ended up probing around in the primary in the primary power supply circuit, and I tested everything, and I couldn't actually find what was going on. And then I eventually got to the high output transistor, and it was short at collector to emitter. So just
you mean horizontal output transistor?
Yeah, that's what I said, wasn't it?
No, high output is what you said.
Oh, okay, sorry, horizontal output transistor. Okay. So just by chance, I actually had another one. So I put it in, and it's starting to smoke the flyback.
Oh my!
So I turned it off, and and then I started doing some reading, and then obviously when the horizontal output transistor goes, it's usually because of, well, it can be because of the flyback. But no, not enough. What you're talking about being in the linear state there earlier. So anyways, I'm just going to order a new flyback, but I want it to find the primary windings and try my new ring tester here.
Oh, you have a ringer, huh?
Yeah.
Oh, that thing. Okay. All right. Well, good. Have fun with that. I didn't have very much fun with that. I don't like those guys. I just don't like those products. There's a cap. They have an ESR meter and that meter.
Yeah.
Yeah. Whatever. For me, it's just even when I had the Sencor LC103 with their and CR7000 with all their fancy ringer tests, I always prefer to just stick in a new flyback. But I always had them, available to me.
Yeah.
So it was easy to do.
Yeah, because I also live in Canada, in order to order one of those, I can't use the regular mail or it won't actually get here for months. I have to use a broker, which is okay. But basically for a $30 USD, like American, that's what they charge the flyback.
Yeah.
It'd probably cost me $55 Canadian or something or more.
Cost of doing business, I guess.
Which is fine. I just wanted to make sure I can test a part before. I just don't want to replace it. But I'm pretty convinced that it is the part that has to be changed.
But you mentioned one thing that I would just kind of want to follow up, and that is you were talking about swapping the CRT from a consumer TV, and you also mentioned that it's a medium res version. Is the dot pitch the same, or?
Yeah, I don't know. I was wondering about that too, because I remember Paul was asking about dot pitch in an earlier workshop, and you talked about that.
Yeah.
Dot pitch is interchangeable for TV lines, right?
No. Lines is the vertical deflection. Dot pitch is the distance or phosphor pitch, the distance between two phosphors of the same color. So if it's like 0.22 millimeters, you know, it's like this. If it's 0.32, it's pretty big. And I think lots of consumer TVs are 0.3 or 0.32, and you want 0.22, I think, or point. I'm not sure. It's been a long time since I've thought about this. So it'd be a shame for you to put it all together and then have it look like shit.
I was just going to mention to Sean, I just did a tube swap with a consumer TV and a Wells Gardner 7500, and it looks pretty good. Like, and there was lots of research, like other people online that said it does work. It looks okay.
But the 7500 standard res, yes?
No, it's a medium res.
Medium.
Oh, is it? Oh,
it's medium.
Okay. Oh, yeah. I'm thinking of, okay.
7400. Yeah, I had a 7500, and that was the first tube swap I ever did. I probably spent about 2 or 3 years like researching it, and because I
thought you were going to say you're going to spend 2 or 3 years converging it, which I can imagine could happen.
No, I don't think I had any issues with the convergence. I don't remember because I haven't done it in so long, but I always mark on the top of the neck, like with Sharpie down the middle across, the ring assembly and where the ring assembly is supposed to mount on the neck.
Yeah.
And I do that on both, the donor TV and the original tube. The reason why I did it was because the green was weak and the red was shorted, and the man that trained me, he rejuvenated it once, and then within about like 2 weeks, it went right back to the way it was with the red short and the dim green. So I was like, oh, okay.
That's always a last-ditch effort, rejuvenation. Oh, we were going to talk about that today, weren't we?
Hey, a quick question about. So what happened was, actually, it's funny because the thermistor for the coil was blown in 2 parts basically. So I put a new one in, but I thought I would eliminate more complication by not actually hooking up the degaussing coil while I try and get this thing started.
I never hook up the degaussing coil until the very end.
Yeah.
Okay. Never, ever.
And yeah, no, I don't know. I honestly just have to keep pushing forward. If it doesn't work, it doesn't work. But in the meantime, I'm still learning lots, and
sure,
all I can do is hope for the best.
Yeah, sure.
Did you swap yokes?
You know what? I haven't at first. I know that's the preferred method. However,
you have to do it. You have to do it.
The chassis and the yoke go together. That's critical.
A lot of people
change res.
Okay.
Yeah.
From what I've seen, if you can get away, if you go 15K to 15K and you measure, it's the same. But when changing res, the yokes are always different.
Oh no, yes, absolutely they are.
Well, the 5500, the medium res is, it's a derivative of the 4900. The 4900, they had high impedance yokes. A lot of people think that like they get a TV and they get the meter out and they measure the resistance and they're like, oh, it's close enough, I'll just keep the TV yoke. Like I don't do that. And in addition, it's not the resistance that even really matters, it's the inductance.
Yeah.
Exactly. Yeah. If you want good geometry, it all sort of has to be really close.
Yeah.
It's the trickiest part of designing a monitor is the magnetics.
Yeah, I wasn't intending on leaving it unless it actually looked good. I just wanted to get the chassis up and running and then see what it looked like and then swap it if it needed it. But would it be okay to leave the original one on for now?
I would put my finger on the horizontal output transistor at the very least and see if it's getting warm or hot. And if it's at all warm, no, I would say absolutely not. I'm typically not worried about the vertical circuit, although it's possible to blow the chip, but probably not because that's capacitively coupled. But the horizontal, and you have to blow the HOT.
I'm going to do that next. However, I think it'll probably be warm anyways, just due to the fact that the flyback's smoking at the moment. So.
Don't hook it up if the flyback's smoking.
Yeah. Okay.
Oh, what the heck, guys? I haven't eaten lunch. I'm going to go eat lunch. Any other questions before we call it quits for the day?
I just had a quick follow-up one. I had posted on the arcade repair group. I have an Orion monitor that had that. I can't find schematics for. And then to humor you, I did give you the neck.
Oh yeah, you know I dropped the
board
ball.
transistors.
I dropped.
No. It's no. I mean, you're a busy guy too. It's. I was curious because there's 2 transistors in the neck board per color.
Right.
Is that typical?
There's 2 different ways to do it, and the higher the bandwidth, the more likely you are to have that. Although Hunter X has that, I think they got 3 per color on the neck board. Yeah, it depends on the design. Whether it's a what's called a common base amplifier, which is what like the Electrohome is, and like that, or kind of a more sophisticated design. In that monitor, is there also an integrated circuit on the neck board as well, an LM1203 or something, or is it just the transistors?
I did not pay attention to if it's there or not.
Okay. Yeah, it's 2 different designs. Lots of ways to skin a cat, but it's a matter of bandwidth. It's usually a faster, you get more crisp video than with just a single transistor. Cool. Everybody okay? Stay safe, everybody. I guess that's it. Anybody?
Happy New Year.
Yeah, same to you. Sort of.
All right, have a good one.
Take care.
It.
Thanks, guys.
Take care, eh? Bye.
Thank you.